Oh boy. Okay, so here's the fun part. We've got 4 washes and we need to keep track of the organic phase. So what makes this synthesis particularly daunting and lengthy is just doing these set funnel operations. So I've got what came over in the receiving flask and I'm going to pour it right in. And I need to figure out which layer is the organic and which is the aqueous. So the first thing I'm going to add to this is 5 mLs of deionized water. And the easiest way to figure out which layer is which is I'm going to take a look at my flask and I'm going to add a little bit of the water. And you can see really what I just added floated right to the top. And if I keep adding more deionized water, it's that layer on top that just keeps getting thicker and thicker. So let me tilt the camera up for you just a little bit. So you can see now we've got a very thin layer on top. And I have a lot more than 5 mLs of organic phase. So note from this observation here that I've got a aqueous layer on top and an organic layer on bottom. Now, something which can occur with this lab, and you'll see this in the directions, is that if it begins to turn pink, and this is due to impurities transferring over, you want to add some sodium bisulfate. In this case, I didn't have that issue. What I ended up with was, a clear layer and a foggy organic layer. So there's no need to add the bisulfate here. So what I'm going to do, hopefully you can see it, is I'm going to take it, I'm going to lower out the organic layer, and it's okay if I take some of the aqueous phase. I really don't need to worry about keeping out the aqueous phase entirely until I get to the last step. This is my organic phase, and I'm like 99% sure this is the aqueous phase. So what I'm going to do is I'm going to add it, and the procedures are pretty explicit here for this very reason, is that we want to hold on to the aqueous cuts in case we make a mistake. Now, I can tell pretty quickly that this is definitely the aqueous phase because one, there's a few droplets of the organic phase, but also if I add a ton of water to it, I don't see it break into 2 layers. So that's definitely the aqueous phase. All right, step 2 is I'm going to pour the organic phase back into the flask or the set funnel. Oop. Make sure it's closed. I've been really embarrassed to do on video. And now I'm going to add 3 milliliters of sulfuric acid and 3 milliliters of water, and I've already just combined them for the ease of this video. But if I pour it in there, give it a good shake. Now, I already see it popping up there. Which is the organic and which is the aqueous? So to test this hypothesis, what we're going to do is we're going to let the 2 layers separate out. I'm going to take my bottle of deionized water here and I'm going to figure out which layer got bigger. So I've got my 2 layers. And I start adding water to it. And I see it's actually, so you see there's kind of 3 layers here. What's happening is the water is getting stuck on top of the organic layer, so I'm going to give it a good shake. And now it's my bottom layer that's gotten bigger on the addition of water. So I know now the bottom layer is the aqueous phase. So once these separate out, I'm going to lower out the aqueous phase. And you're always free to add a little bit of water to figure out what's going on. You'd rather add some water to your system and create a little bit more waste than throw away the correct layer. Alright, so this is what I think is my aqueous layer. And again, I'm going to test this. Oops, sorry, I didn't realize you couldn't see it there. To test it, I'm just going to take some deionized water. Throw a bunch of water in there and you don't see kind of a bubble of water forming, so this is definitely the aqueous phase. Alright, next step is I'm going to wash it with 5 mLs of sodium hydroxide. So I add a little bit. Give it a good shake. It's going to get a little hot because we're neutralizing the sulfuric acid that was in there. Let the two layers separate, and it's going to get more stubborn now. As we start purifying out the final product, it's going to get harder and harder to do this type of separation. Like the layers are just going to take longer and longer to separate. But I see my two layers. Hopefully you do too. What I'm going to do, just to verify which layer is which, I'm going to take a little bit of deionized water, and I'm going to add it. What I see is that the top layer is getting thicker, so that's my aqueous phase. So I'm going to drain out my organic layer. Now, there is a common problem with this step, and I will bring it up here. Every now and then you get some stuck at the top, so if you're curious why I'm putting it back underneath. You can't get rid of that little drop that's in the top. It's stuck there by surface tension. So we're just going to accept that as part of our losses. And let's collect what we think is our aqueous phase. And again, to verify that this is indeed an aqueous phase, I got my beaker liquid, hit it with a bunch of water, and I don't see a second phase forming, so this is definitely aqueous phase. Alright, last wash. Let's pour this back in. And this last wash is going to be saturated sodium chloride, 10 mLs of it. Give it a good shake. Now, every now and then you'll get some salt that crashes out, particularly if you had a lot of impurities in the organic phase or you didn't do a good job of separating it out the previous time. If that's the case, just add a little bit more DI water, shake it up, and that should dissolve the salt. This, as the name implies, is sodium chloride, so if there's something in there that's pushing the sodium chloride out, you can just redissolve it. And once my layers begin to fuse together, what I want to do is take it and add a little bit of water. And again, if you're comfortable with where the aqueous phase is, you don't need to do this. I'm just doing this for illustrative purposes. We can add a little bit of water. And what you see is that the top layer here is getting bigger when I add the water. So the bottom layer here is my organic phase. Alright, so now to drain the organic phase into a beaker. And I just want to verify that this is an aqueous phase, so I'm going to hit with some water. And I definitely don't see two phases, so this is definitely my organic. So now we're to the last step. And the last step here is to apply a little bit of magnesium sulfate. And this will remove any water that's kind of stuck in the organic phase. So give it a little swirl, and it's looking like, yeah, it's not sticking together anymore. Oh, actually no, there it goes, it's starting to stick. So I'm going to give that just a minute. Add a little bit more magnesium sulfate to it. I can see now, looking down, it's not clumping together. So our tearing scale over here. So the last step is to decant this into a pre-weighed beaker. And there we go. That's our isolated organic product. So now we're going to move on to characterization.